Back in action, guys. Let's do one more big function where we do all the algebraic work. Let's start with our pre-calculus knowledge on how to sketch the graph. Now, what we would do on the graph sketching is we'd say, can we factor the top? Can we factor the bottom? No. So what can you do? Well, I could say the x-intercepts are any x value that make the top go to 0. So it looks like 0, 0 would be an x-intercept. And FYI, if the origin is the x-intercept, it's also the y-intercept. So let's not waste time there. Vertical asymptotes are any x value that makes the bottom go to 0. So I'm going to say there's a vertical asymptote at the vertical line x equals 1/2. Horizontal asymptotes, there's no horizontal asymptotes. Instead, we have a slant asymptote. Why? Because this function is top heavy. So I need to do a little quick long division. So it looks like 2x times 1/2 x is what would give me 1x squared. Let me multiply back through. 1/2 x times 2x is 1x squared. 1/2 x times a -1 is -1/2 x. So I'm going to bring that down. Let's see, I've got 1/2 x. Yuck. What should I say? Maybe plus a fourth? Would that work? Is 1/4 times 2x going to be 2/4 x or 1/2 x? Yes. Minus a fourth. Now remember, oops. Little mistake. Sorry about that. I need to put 1/2 x there, minus a fourth. And then remember that it doesn't matter that there's a remainder or not. 2x won't go into 1/4. That just tells you to stop dividing. Put a y in front of the 1/2 x plus 4, and you've got your slant or diagonal line that's going to serve as your slant asymptote. So the quick graph on that. Let's see here. Let's see. Can I work this? I'm trying to see if I've got enough room right here, if you're wondering what I'm doing. I'll go skinny with my graph. So let's see. 0, 0. Vertical asymptote at 1/2. So I'll dot it in right there. And then slant asymptote, you're going to have a fourth and then up 1, right 2. So up 1, right 2 would be about right there. So there's my slant asymptote. Now, my guess is, without doing a whole lot more work, that from 0, 0, I'm going to follow the graph this way, and then I'm going to be in the opposite part of the cross. So I think that is my graph. If you want to double check on the calculator just to see, don't want to spend too much time on this one part. This is just a quick summary of what you already know. So yes, I've graphed it on my graphing calculator, and it does look like what we've got, which is a good kind of sideways hyperbola. Now we need to get critical values, so I'm going to switch gears, and I know on the critical values that I need to find the derivative. Well, how are we going to do that? Well, do you remember that we're going to have to use either the quotient rule, or you could make it x squared times 2x minus 1 to the -1 power, and then you would use product rule and chain rule. I think I'm just going to use the quotient rule. So low d high minus high d low over low low. So got to work that out, see what's going on. Looks like I've got here, when I distribute, 4x squared minus 2x minus 2x squared all over 2x minus 1 quantity squared. I'm going to go just a little bit further. I'm going to have h prime of x, because the more I can clean up, the better. 2x squared minus 2x over 2x minus 1 squared. I'm going to go just a little bit further because I noticed the GCF comes out of the top. Nothing. Oh, yeah, I just made a real large boo-boo. I was looking at the bottom instead of looking at the top. So nothing reduces. So I'm just going to leave it right there. But here's the thing. If I'm going to find the critical values, I need to look, does h prime of x fail to exist? Does h prime of x ever equal 0? Well, you might look at this and say, well, sure, h prime of x is going to fail to exist at x equals 1/2 because that's what's going to make the bottom go to 0. But x equals 1/2, if you look at the original function for h of x, x equals 1/2 isn't in the original domain. So because this is not in the domain, I'm going to strike that as a critical value. It's actually not a critical value. Instead, it's a vertical asymptote. So if it's not a critical value, there's no way that it could be a max or a min, right? Does h of x ever equal 0? Yes. If the top is 0, the whole fraction equals 0. So it looks like it's 0 and 1. So these are my only critical values. So step 2, done. It's time for me now to build my sign chart. So I need to put 0 and 1 on my sign chart. I'm building here. So less than 0, let me pick -5. Between 0 and 1, I can't pick a half because a half is not. You know what I'm going to do? Let me amend this, and I can do this pretty quickly. I can't pick a half because 1/2 is not in the domain to begin with. But, I know that 1/2 is not a critical value, but it does have some influence on whether the graph is positive or negative. So I think I'm going to keep it on my sign chart, even though it's technically not a critical value, and I'm going to use it to help me with the sign chart. That helps me figure out that it would probably be good for me to pick 1/4 or 0.25 here, 3/4 or 0.75 here, and then I'll pick 10 there and keep it simple. I think I'm going to get a better looking sign chart if I have it. And the sign chart's going to give me more readable information. So again, my thinking is, even though this is technically not a critical value, I still think it's information that needs to go on your sign chart so that you don't misinterpret some of the information you've got. All right, so what do I plug into? You're going to plug into the most simplified, i.e. factored form of the derivative. So I'm going to plug into the fraction that I've kind of boxed in green. So let's see here. When I plug in -5, 2 times -5 would be -10. -5 minus 1 is -6. The bottom's always positive because you're going to square it. So my results there is positive. When I plug in 0.25, 2 times 0.25 is positive. 0.25 minus 1 is negative. The bottom's always positive, so my result there is negative. Plug in 0.75, so I'm going to get 2 times 0.75 positive. 0.75 minus 1 is negative. The bottom's always positive. No sign change. And you know what? No sign change there is good, because that just emphasizes that the x equals 1/2 is not a max, it's not a min, because I don't get a direction change. When I plug in 10, 2 times 10 is positive, 10 minus 1 is positive, the bottom's always positive, so my result there is positive. Can you quickly say, that means f of x increases, decreases, decreases, increases. So, something else that I want to look at is, I've got a max, and then I've got a min. So I've got two two extrema. So let's see, when we look at it, if what we're seeing fits. I can tell where the graph is increasing and decreasing. I'm not going to make you write that out as a separate statement. Your graph is, or your sign chart's clear. Let's see. I am saying that I've got a max at x equals 0. If I do h of 0, well, I already know that I get 0. So the max is at the point 0, 0. I already knew that 0, 0 was a point in the graph, so that was goofy. I've got a min at, according to my sign chart, x equals 1. So h of 1 would be 1 squared over 2 times 1, which is 2, minus 1. So I'm getting a half. So I'm getting a min at 1 comma 1 half. Now, when I refine the graph, I'm going to use all the information I know. So I'm going to make my graph even a little better than the red graph. And tomorrow we're going to get into where you do basically very little red graphing, and we just kind of hold off on our graphing until the end. The reason I'm showing you the original graph today, is just to connect what you already know from pre-calculus with this new garbage. That's all. So I've got 0, 0. I've got a vertical asymptote at x equals 1 half. Or I already know that I've got a slant asymptote. I'm not going to be perfect about it. I'm going to try to get the slope of the slant asymptote reasonable, but I'm not going to go crazy. So that's all from the original information I did in red. Now, 0, 0 I know is a max. So that is why, for instance, what I'm doing could not happen. I'm going to do this in pink. Does the 0, 0, you might have asked yourself earlier, does it have to be the max? Could the graph have gone up like this a little higher and then come back down? Okay, well, no, because that would have added a root to the graph, and we can't do that. But now you know for sure, no, that could not happen because 0, 0 is the max. So it has to look like this. It has to. Now, I can also plot the point 1 comma 1 half. So 1 comma 1 half would be right about here. So I think my slant asymptote's not quite slanted as flat as it should be. But that's a min. And so I know the graph has to be above, like that. So that point I just plotted at 1, 1 half, that is not a perfectly placed point because it would not be on the slant asymptote. I think the slant asymptote's going to actually go below the pink point, but I didn't take enough care with my graphing. It would look better, for instance, on graph paper. So there you've got everything you need. The two graphs essentially look alike, but again, just trying to show you that what you did when you were in your classes in pre-calculus, same thing as now. Now, I want you to look at these last two examples. I want you to notice that on these last two examples, I've got the exact same graph. So am I just having you do the same problem twice? Oh no. So we are going to go back and look at the relationship between the graphs of f of x and f prime of x. To do this, you need to make sure that you are clear what graph you're looking at. So on this first example, notice I've labeled the yellow graph as the derivative. It's f prime of x. And if I were you, while I'm kind of talking, I'd go ahead and sketch this graph real fast because you're going to want these in your notes. Now, let's fill in the stuff that we absolutely for sure know. Well, one thing we know is if the derivative is quintic, what could you say that f of x must be? Well, are you thinking it's got to be a sixth degree polynomial function? I hope that's what you were thinking or saying out loud. If f of x has critical values at, all right, let's think about it. F of x has critical values if f prime of x at any place does not exist. Well, my yellow graph exists everywhere. There's no asymptotes, there's no jump discontinuities, there's no holes in the graph, there's nothing like that. So this is not an issue. I also have to look at where f prime of x is equal to 0. Well, do you see f prime of x equal to 0 anywhere in the graph? And yes, at these x-intercepts of the f prime of x graph, that's where f prime of x equals 0. So I'm going to say at x equals -3, at x equals -1, at x equals 2, and 3, 4, 5. Oh, so I've got 4 critical values. I'm going to do a sign chart. Now you're going to get to where you maybe don't have to do sign charts on every single one of these kinds of problems when the graph is already shown. But I'm going to do this sign chart because I want you to recognize that I'm breaking it down the same way I've been doing. So I'm going to look at f prime of x, and then I'm going to make inferences about f of x. So do you see before -3, before x equals -3, right here, I see that f prime of x is positive. Between -3 and -1, right here on the graph, I see that f prime of x is positive. From -1 to 2, I see that my f prime graph is below the x-axis, making it negative. Between 2 and 5, f prime is positive. And from 5 onward, the graph dips below the x-axis and is negative. Therefore, f of x is positive, positive, negative, positive, negative, increase, increase, decrease, increase, decrease would have been a better way to say that. So we may not know where to place the graph of f of x because I would need at least one point on the graph to know generally where to place it, but I can tell its shape. So its general shape is going to be, and let me remind you that I know at -3 the slope is 0. So it would have to be something like the graph increases, flattens out, and increases. So I've just done these two parts of the sign chart. Then the graph flattens out and decreases. That's this part of the sign chart. Then the graph flattens out and increases. That's this part of the sign chart. Then the graph flattens out and decreases. So that's the general shape of f of x. Again, I don't actually know where to plot the points because there's no way for me to tell where the x-intercepts are or what the y-coordinates of the extrema are. So just general shape, kind of an interesting activity. Are you all right with this? If you need a minute and you need to rewind this or just pause the video and talk this over with each other, do. Don't hesitate. Recopy this same function. This is our last example. I'm pausing to give you a minute to quick sketch. This time, the graph is labeled as f of x, not f prime of x. So our thinking must change. So if f of x is quintic, its derivative must be, answer out loud, shout at the board. Yes, I heard you all the way at the math contest. It's quartic. F of x has critical values at. Okay. Again, wherever f prime of x does not exist, or wherever f prime of x is equal to 0. Now, for f prime to not exist, it means you've got to have a corner or a cusp. No. You have to have vertical tangent lines. No. Or you have to have discontinuities. No. So this is not your issue. Now, for f prime of x to equal 0, you've got to have flat places on the graph. So look, the graph kind of flattens out here, it flattens out here, it flattens out here, it flattens out there. So I'm saying that my critical values will be at x equals -3, -2, +1, and +3. If you get stuck and you're not understanding something, pause the video and then talk with each other, because I know that you all together can figure this out. All right, so we need to sketch f prime of x. So we're going to kind of go backward. I've got -3, -2, 1, 3. I'm going to build my t-chart or my sign chart, but notice I'm going to do it in reverse of what you're used to doing it. So I have f prime of x, f of x. Now, I'm going to break this down. Normally, I get the sign of f prime of x, and then I can figure out whether f of x is increasing or decreasing. Here, I'm going to go the other direction. So I can see that all the way to x equals -3, f of x is decreasing. From -3 to -2, f of x is increasing. From -2 all the way down to +1, the graph is decreasing. From 1 to 3, the graph is increasing. And from 3 onward, the graph is decreasing. Now, infer backward, that means the derivative is negative, positive, negative, positive, negative. Meaning below the x-axis, above the x-axis, below, above, below. Whoa, how are you supposed to graph something from there? Well, let's see here. I know that -3, -2, -1, or +1 and 3, I know that their f prime values are 0. So -3 is an x-intercept on the f prime graph. So is -2, so is 1, so is 3. Okay? Now, I could go further. Let's do. Okay? At this point, I know that from -3 backward, the graph is below the x-axis. And remember, I know this is quartic. So below the x-axis would just have to kind of look like that. I know that from -3 to -2, my derivative graph is above the x-axis. So it would have to look like this. I know from -2 to 1, the graph is below the x-axis. I know from 1 to 3, the graph is above the x-axis. And I know from 3 onward, the graph is below. Does that look like your standard quartic or W shape? Yes. Now, the one thing I was going to ask you about is, can you tell where to put the points on this graph? Like, for instance, it looks like this is about 2, 1. Can you really tell where that goes? The answer is no, because you don't have an equation for f prime of x to plug into. So, I could guess, but no, I can't really tell for sure. So that's it, guys. You are ready to do a couple of things. Number one, we're going to be working on the next assignment right now in class if there's any time left. Number two, we're going to do some AP exam registration. Have a great day, and I'll see you tomorrow.